It's so weird having to teach from home. I hope everybody is healthy. I hope your families are healthy. And so what we're going to do today is we are going to start with this packet that I gave you last time we were together, and it is on the beginnings of logs and graphing logs. So I also put it up on the Google Classroom again if you need to open it up. So one of the things I want to do is I want to actually start from the beginning with this, just in case anybody was absent or it's been a while. I know you probably haven't been studying logs and exponents, so we're going to go back over this one from the beginning and work through it. And then I'm going to ask you to do the homework section of it, which would be the second 2 pages. Now, there's also this skew that you can scan with your smartphone, which will bring you to a video, and you can watch the author of this workbook also work through it to help you out. So you'll have me, you'll have him, and then I'm going to want you to try the second 2 pages, which of course then I'll put up the answers and I will take any questions that you have. If there is any problem, please comment either on the classroom or email me as soon as possible so that I can answer you as soon as possible. All right, so we're going to get started. You do need your calculator. Now, the other thing is, if you have not downloaded Gen X for your Apple to get the graphing calculator on your iPhone, then please make sure you do that. Pause this video and get that taken care of. If you have an Android phone, I believe you can download the TI-83 or TI-84, right, and get the exact one. So you do need a graphing calculator for logs and for exponents if you're going to see the pictures. Your calculators do have the log key, but they don't have the log base key either, and we have the log base key on this. So, all right, well, let's get started. The first question is talking about the graph of the exponent 2 to the x power, and they gave you the table and they gave you the graph. Now, I'm not going to draw the picture, but I am going to start talking about, again, the one-to-one function. Is this exponent y equals 2 to the x? This is a one-to-one function because there is no repeat on the domain or range. So you can look at your picture, and if you can do the vertical line test on your picture, it's a function, and if you can do the horizontal line test, it's a one-to-one function. So because this is a function and it's a one-to-one function, I should write is a one-to-one function, that means its inverse is also a function. So this was a really big deal when we did chapter 4. So if a function is one-to-one, then its inverse is also a function. Now remember, when we do the inverse is when we switch x and y. So the inverse, I'll just write this here, switch x and y. Now if you were in school last Tuesday, Wednesday, and Thursday, we did this. You have these in your notes. So if you weren't in school any of those days, you should absolutely get down anything that you're missing. And this is following the packet. So if I switch x and y, let me just see if I have a color that's a little bit darker. If we switch x and y, then the inverse would look like this. We would have x is equal to 2 to the y. Now there's no x key on the calculator. So now we have the problem is, how would I get this on the calculator? So we said, if we now read from the exponent, so this is the difference that I was talking to you about. Exponents, we read from the base up to the exponent. But when we now talk about a logarithm, we're reading from the exponent down to the base. So it's opposite. We look at this in the opposite way. So when I read this, I am now saying y is the exponent on a base of 2. So that's exactly what I'm saying here. And this is my cat Finnan, and he wants to be a part of the class. I hope you'll welcome him in. So now if I write this in math terms, the word is always equal. Exponent means log. Remember we had said too, it was either Tuesday or Wednesday, either the 10th or the 11th, we were saying that an exponent and a log, they mean the same thing. They're synonyms of one another. So now again, since I'm reading from the vantage point of the exponent down to the base, y is the log on a base of 2 for the power of x. Remember, the answer to an exponent problem is called the power. If we looked up here, we would say this is 2 to the x power. So y is 2 to the x power. So again, base and then exponent and power. So when I go from exponent form to log form, I am going to be on a graph. I am the inverse. I am switching x and y. So now I'm going to have to erase this. So I hope that everybody has this down on their notes. So you should, because this was part A, part B, and part D. Now we're going to take a look at the graph, and we're going to look at a picture of it, and then I'm going to walk through how to do it on the calculator. So pause the video at any point to get any of the notes you're missing. So before I erase anything, I'll just hold this so the notes are hopefully nice and clear for you, the whole thing. I only have a small whiteboard at home. And I've never really taught remotely before without an audience, so I hope I'm being clear. If there's things that you're not following, you do have to let me know. Give me, send me an email, send me a message on the Google Classroom. Let me know what's not clear, what could be better, and I'll see about changing it. All right, so here's my graph now. So here's x and here's y. Now, when I'm graphing a log, which I'm going to write up here again, y equals log base 2 of x. Well, I know I'm going to go through the point 1, 0. We talked about this as well. And the reason for that is look at your exponent graph. Your exponent graph was going through 0, 1. And I switched x and y. So now I'm going through 1, 0. On your exponent graph, you also went through the point 1, 2. Now I'm switching that. I'm going to be going through 2, 1. Also, I told you that whatever the base is, if this is your B for base, you will always on a log graph go through the base and the number 1. This will happen, so if your base was 7, you'd go through 7, 1. If it was 5, you'd go through 5, 1. You always go through the base and 1. And now if we keep flipping the points on the table from above, where you have on your 2 to the x table 2, 4, we're now going to go through 4, 2. So here's 3, here's 4, 4, 2. And then the next point on your 2 to the x table was 3, 8. But here, if I flip it, I'm going from 4, 5, 6, 7, 8, just to get up to 3. They are switched. And here would be my log graph. Now, on the exponent graph, which I actually should put on here just for this next part, again, you went through 0, 1, you went through 1, 2, you went through 2, 4, so I got to put 4 on there, and you went through 3, 8, which would be all the way up here. So let me put on my 3 and my 4, 5, 6, 7, and there's 8 all the way up there. So now here's the 2 to the x, and we just have to talk about the asymptote again, because I know you guys probably have not been thinking about that either. When we had exponents, we did spend a lot of time on this with exponents. Exponent graphs do not touch or cross the x-axis. This is the horizontal asymptote for an exponent. The horizontal asymptote is the line y equals 0, but we also know it is the x-axis. Now, when I switched the x and the y, and now I have my log graph, which is here in blue, what that did was that switched my asymptote from being the x-axis to being the y-axis. So on a log graph, so for my log graph, I now have a vertical asymptote, which is x equals 0, or the y-axis. Now that matters a lot. We talked about this a lot because we also said that the domain of the exponent graph is all real numbers, and the range was only positive above 0. So let's write this down, and I'm going to keep doing the exponent in pink, and I'm going to do the log in blue. So for my exponent graph, the domain was, that's curved, negative infinity to positive infinity, all real numbers, and the range, and I'm going to get rid of all these notes now on the inverse, just so I have room to write. So the range was 0 to positive infinity because we were only positive numbers. Now if we look at the domain and the range on my log graph in blue, my domain is 0 to positive infinity. And again, I'm above 0. I can't touch 0. And my range is now my negative infinity to positive infinity. So everything switches. When you do an inverse, everything switches. Your x switches, your y switches, your domain and your range switch places, and your asymptotes even switch places. All of that matters to us in math. So hopefully that is something that you understand now. Even if you didn't get it when you were in class, maybe it makes sense to you now. I have to hope it does. Now, the next thing we have to talk about is when we were actually converting from exponents to logs. How does that conversion work nice and quickly? Well, it's a flip of the power in the exponent. It is never a flip of the base. The base remains constant when we convert from exponent form into log form. So let's talk about these notes at the bottom of the page. When you have y is equal to log base b of x, and you want to convert this into exponent form, remember, this is the base. That means exponent. So y is the exponent. That means this is the exponent, and then this is the power. So if I can even put a parenthesis on it. This is considered the power. Now the base doesn't change. When it's on a log, it's nice and small, but when it's in exponent form, it's nice and big. Now what changed from log form to exponent form is these guys are going to flip. And then this would be the power is the base to the exponent y. And I said in class, you just have to flip your hands around. So here's the exponent and the power, and now here's the exponent and the power. And I told you, if you're flipping your wrists, you're probably doing it right. So again, here's still the base. Now we have the exponent and the power. So the next page had a whole bunch of problems. And these problems on exercise 2 for A had log base 2 of 8. Now, we can do two things. We can put it into exponent form and we can solve it, and then we could type it into the calculator. So that's why I need you to have your calculator. So the first thing is, if I'm going to do this using algebra, which is this up here, then I'm going to say, I don't know what this equals yet. So now the base is 2, and I am going to, again, flip the exponent and the power. They're going to flip. 2 to the what power is 8? Well, I know that x has to be 3, because 2 to the third power is 8. So now, if I check this on the calculator, this is when you will have to turn your calculator on, and let me try to go. And then you hit math, and you have to go all the way down to log base, which is A. I hope you can see that. I have no idea if you can or not. And hit enter. And in the small base, you're going to put a 2, and then you need your cursor key, and you're going to put your 8 and cursor out, and then you're going to hit enter. And you get 3. Hopefully you can see the 3. I don't know how clear this is on the video. Now the next thing is you can type this in using the change of base formula, which is using the common log over here. Now this is on a regular calculator, even your iPhone calculator, without using Gen X. And you can type in the log of the power, so you could type log 8, close the parenthesis, and divide that by log 2, close the parenthesis, hit enter, and you still get 3. And it still says 3. So I'll write that here on the board as well. Or you can say log 8. Remember I said start at the L and you hit the 8 first. Divide it by, start at the bottom of the L, you hit the 2. Log of 2. And you get 3. So this is pretty important. And just in case it's not clear, I'm going to hold this up for you. So I'm going to go through the rest of these a little bit more quickly, and then I'm going to ask you to do the next 2 pages, which I think you already had to do for homework. And then we'll have the answers put up for that as well, okay? All right, so the next one is log base 4 of 16. So B log base 4 of 16. Again, if you use the flip, we have 4 to the x equals 16. So x equals 2. And on the calculator, you could have typed log of 16 divided by the log of 4, and you're still going to get 2. Part C, log base 5 of 625, again, equals x. 5 to the x is 625. 5 to the 4th power is 625, so x is 4. Or the log of 625 divided by the log of 5 is still going to give you 4. So you should be able to do it both ways. So I'm going to do them both ways just so you can practice. D, we have the log base 10 of 100,000. Now guys, I want you to know, this is the same as the log on the first column of your calculator. This is a common log. The 10 can be invisible. So I could have said log base 10 of 100,000, or I could have said just the log of 100,000. So you could type that straight in using the log on the calculator, and you would have gotten right away x equals 5. But if I take this guy over here, this would have been 10 to the x is equal to 100,000. And 10 to the x is equal to 10 to the 5th. So x is still 5. Either way, you could do it either way. Now, when you get into fractions, you're going to want to be really careful that you remember your negative exponents. So when you have e, which is log base 6 of 1 over 36, you want to say to yourself, well, what's the connection between a base of 6 and 36? And that connection is 1 over 6 squared. Then you say, well, I don't really want a fraction. I want the 6 squared out of the fraction. So that's your negative exponent. So now this would then become log base 6 of 6 to the negative 2nd power. Well, if you have a log base 6 and then here you have a base of 6 on an exponent, these guys all end up canceling out and the negative 2 drops down. Now you want to check that out. You want to just make sure that I'm not lying to you, which of course I would never do, but go back to your beginning. The log, so if I hit log and I hit 1 divided by 36, and I divide that now by the log of 6, I get negative 2. You're still going to get negative 2 no matter which way you go. Alrighty, so now let's just finish this up. When you have, this one? Okay, so now part F, when we have the log base 2 of 1/16, same thing, you can type it in exactly the way it looks. You can take 16 and think about a base of 2. The log base 2, this would be 1 over 2 to the 4th. So then this would be the log base 2 of 2 to the negative 4th. which now makes this whole thing -4. So algebraically, you could have used your exponents, or again, typed it in right away, went straight to -4. Please know how to do both. It's always important to know how to do things more than one way. G is using the radical. Log base 5 of the square root of 5. Now again, use your calculator. Type in the log of radical 5 divided by the log of 5. You're going to get 1/2. Now, why are you going to get 1/2? Well, the log of 5, and a radical has an invisible index of 2, so this would be 5 to the 1/2 power. Well, here's a log with the base of 5, an exponent with the base of 5, and here's an exponent with the base of 5. These guys will cancel out, and you're still getting your 1/2. So please, please go back over your exponent unit as well. Excuse me. And so now I have h. So I have log base 3 of the 5th root of 9. Well, that's crazy. But again, you can type this in. And when you do, you're going to get 2/5. Or 0.4. And the reason for that, again, is let's take 9 and the base of 3, and let's write this as log. 9 is 3 squared. And this index is 5. So that's 1/5. So this actually cleans up to the log base 3 of 3 to the 2/5. Well, again, they cancel. 2/5 drops out. And so your calculator would give you 0.4, but of course you'd hit math enter twice and you would be back. And the next two questions are asking you all about just using the calculator and looking at the table. You have to know what a y-intercept is. Please tell me you know that that means where we're crossing the y-axis. So you have to type this in on y equal, and you can look right at the table. Or if you know that the y-intercept is the place where x is 0, so y-intercept when you have the y-intercept, this means 0, comma y as an ordered pair. X has to be 0. So I could take this algebraically, and I can write y equals, and the problem was log base 2 of x plus 8 plus 9. And I could algebraically put 0 in for x. So then this would be, algebraically, log base 2, 0 plus 8 would be of 8 plus 9. And the log base 2 of 8 we saw before, but again, type in log of 8 divided by the log of 2. You get 3 plus 9 is going to give us 12. So there we are algebraically. We want to do it graphically, then we have to go, and this is where you absolutely need your Gen X. You need to go to y equal, clear out anything that's there, and you have to hit math, and you have to go down to log base, which is a. So you have to hit math a, enter, and then on your calculator, you have to type in exactly what's here. Log base 2 of x plus 8. Jump out of that and hit plus 9. And then, so now you have that all typed in. And then you have to go to the table. Second table. And my table is all the way at 30 because clearly I did something else on this. So remember, table set above the window. Second table set. And let's go to 0. And go second graph. There it is. 0, 12. My y-intercept is 12. And remember, when they ask you for an intercept, it's only that one. It's only that one value. And now, exercise 4, between which two consecutive integers is log base 3 of 40. Well, again, you got to type this guy in. Now, I know that this is between 3 and 4. And the reason I know that is because I know my exponents for 3. I know 3 to the third is 27, and I know 3 to the fourth is 81. 40 is clearly in between these two numbers, so between 3 and 4 for the exponent. Remember, that's the exponent. So there you go. Common logs. This is using that log key on the front, on the first column. This is the log that's on all calculators. Doesn't matter. You can even pull out your old calculator from middle school. There's a log key somewhere on it. And so you type in, so now I am doing exercise 5 over here. If you have the log of 100, you're going to get 2. And you're going to get 2 because, again, the invisible base, let me use green, the invisible base is 10. And 10 to the second power equals 100. So again, you can keep the base and switch the power and the exponent power, and there you go. So A gave you 2. Now B, they give you the log of 1 over 1,000. Now 1,000 is 10 to the third, but we flip it, and this equals the log of 10 to the negative third, and since this has that invisible base of 10, the answer to this is simply negative 3. Then we have part C, the log of the square root of 10. Well, this is the log of 10 to the 1/2 power, and that invisible base of 10 cancels, and we get 1/2. So, all right, at this point, you should be doing, or if you have or have not already done, the next 2 pages in this packet, and I asked you to do 1 to 9. If you want to try 10, feel free, but 1 to 9 is absolutely what you should be doing. So you should, at this time, pause the video so you could go back and look over things for help as you need it, or just turn it off, and the answers are going to be posted, and please, please send me any question that you have. All right, good luck. And I do miss you guys. I miss going to work. This is crazy for all of us. I hope you're all doing okay.